Okay, we're going to start working on sectors, segments, and arc length today. Pay particular attention, 3 different sections, so if you need to rewind and go through the details, make sure that you do that. Okay, a sector of a circle is a section bounded by 2 radii and an arc. You can always figure out what fraction of the circle you're talking about by dividing the central angle by 360. So if we have a 52-degree angle, that means we have a 52-degree arc, and 52 out of 360 is 13/90ths of a circle. To find the area of a circle, we find the area of the whole circle and just keep that fraction of it. So the area of a circle, remember, is pi times radius squared. So the area of a sector is the area of the circle times the degrees out of 360 that that sector takes up. So it's that fraction of the circle, that fraction of the circle. So this part right in here, okay? Okay, we're going to apply it to a couple of problems. Find the area of each sector, give your answer in terms of pi, and then round it to the nearest hundredth. So we have sector JKL. Find the area of a sector, pi r squared times m over 360. Pi, radius is 16 squared times 36 over 360. Okay, if we want it in terms of pi, we have to do a little bit of work here. 16 squared is 256. 36 over 60 is a tenth. So if I take 256 divided by 10, in terms of pi is 25.6 pi inches squared. Then I go ahead and I take my calculator and I plug in 25.6 times pi. I have to find the pi button on my calculator. There it is. And I get 84.83 inches squared. 84, did I say? 80.43 inches squared. 80.43 inches squared. So double check the work. Okay, next one. Okay, think of the windshield wiper blade. So think of, I'm just going to draw a little picture here because you can't see me and what I'm doing. So here's your windshield. You have this wiper blade and it comes up and it covers a certain amount as it goes back and forth. Okay, really that's in the form of a circle. Okay, it's just not rotating all the way around. So your wiper blade is 18 inches long and it's going to rotate 122. It's a little more than 90. Okay, so we're trying to find the area of this sector. Okay, we know that central angle is 122. Okay, so again, pi times radius squared times the degree out of 360. Okay, this one we just need to find to the nearest square inch. So I'm just going to plug into my calculator 18 squared. I'm going to multiply it by 122. Then I'm going to divide it by 360. And then I'm going to multiply it by pi. Okay, so to the nearest square inch, it's 345 square inches. 345 square inches. Okay, so that was sectors. And now we're talking about segments. Segment of a circle is a section bounded by an arc and its chord. Bounded by an arc and its chord. So the question is, how do I find the area of this segment in here? Okay, it's rounded off here, which makes life a little difficult for me. It's not through the center, so I can't find it as a half circle. So I'm going to have to do a little extra work here. Okay, so to find the area of a segment, use what you know about the area of the sector containing the segment. Okay, so I'm going to find the area of this big sector here, and I am going to take off what I'm coloring in blue here. I'm going to take off the area of that triangle. So, okay, the area of a segment is the area of the sector minus the area of the triangle. Some of these are really easy. Some of these are a little more challenging. So here we go. Okay, first one's the challenging one. Find the area of segment L and M to the nearest hundredth. Okay, so my job is I'm going to find the area of the sector, then I'm going to subtract the area of the triangle. Okay, so the area of the sector, remember, is pi r squared times m over 360. Okay, pi, radius is 9 squared. Degrees is 120 over 360. Okay, so I have pi times 81. 120 over 60 happens to be a third. So this is 27 pi. For right now, I'm going to leave it as 27 pi square centimeters. I will calculate what it is later. That way then I'm not rounding twice. Okay. The second thing that I need to find is the area of the triangle. Okay. That's a little more difficult because this triangle here has an angle here of 120 degrees. The only way I can find an area of a triangle is to find the height of that triangle. So I'm going to have to draw in that height. If I draw it in so that it's perpendicular, it bisects this according to the theorem that we learned in the last section. If I have a radius and it's perpendicular, then it's the perpendicular bisector. Okay, so it also bisects that angle. So this is 60, that's 60, 30, and 30. So we have a 30, 60, 90 right triangle. So if I follow my rules for a 30, 60, 90 right triangle, 30, 60, and 90, across from the 30 is x, across from the 90 is 2x, and across from the 60 is x root 3. So this is across from the 90. Across from the 30 is going to be 4.5 or 4.5. And each one of these guys, since they're the same on both sides, is going to be 4.5 times the square root of 3. To find the area of that, I have to take 1/2 base times height. Okay, the base of that is all the way across here. So that's 9 times the square root of 3. The height is 4.5. Okay, so in order to find the area of the segment, I'm going to take that 27 pi and I'm going to subtract 1/2 times 9 root 3 times 4.5. Okay, and I'm doing it this way so that I remember that my rounding isn't going to affect what I have. Okay, so as I plug it in, I'm going to do the one on the right first because I don't have the calculator you can plug everything into. So I'm going to take 1/2 times 9 times the square root of 3 times 4.5. It gives me 35.07. Okay, and then I'm going to take 27 pi and I'm going to subtract, oh, I forgot what it was already. Did I do that? Okay, 0.5 times, I got to do this again, 9 times 3 square root equals times 4.5. 35? Okay, 35.07. There it is. Okay, let me do it in this order. 27 times pi is 84.82. There we go. Too much to try to do it and all that. So 84.82 minus 35.07 gives me, to the nearest hundredth, 49.75 centimeters squared. And again, the longer you keep and not continue to round, the better you are in the end. Okay, here's another segment, okay, to the nearest hundredth. So you find the area of the sector first. Remember, that's pi times radius squared times m over 360. You can tug in pi. The radius this time is 4 squared. And this time is 90 over 360, which nicely enough is a fourth. So we have 16 times a fourth, or 4 pi meters squared. Okay, again, I'm going to leave it till the end. And this time I'm going to find the area of the triangle. Okay, don't make a mountain out of a molehill here. This one's easy. In order to find the area of a triangle, you need a base and you need a height. So it means you need a right angle. I already have it. So that means my base is 4 and my height is 4. So I have 1/2 4 times 4, or 8 meters squared. Okay, now I just go in and I subtract. So I'm going to take 4 pi minus 8. Okay, so I'm going to take 4 times pi and I'm going to subtract 8. It gives me 4.57 meters squared. Okay, that one's the easy one compared to the other one where you had to use the 30, 60, 90 right triangle. Okay, last thing is arc lengths. Okay, arc length is like perimeter, so think of it as string around a circle. Okay, we're going to cut off a certain part of that string. Okay, so arc length and area of a sector are really the same, with the exception of the fact that instead of finding the area of the circle, I'm going to go ahead and find the circumference. Okay, so the only thing that changes is here. It's the circumference of the circle. Okay, so here we go. Okay, find each arc length, give answers in terms of pi, and round to the nearest hundredth. Okay, so arc length is 2 pi r times m over 360. So 2 pi times the radius, which is 8, times 134 over 360. Okay, so I take 16, which is 2 times 8, times 134, and I divide that by 360. Gives me 5.95555. So I'm going to just say that this is 3. I'm going to say it's 6 if it's 5.9. Okay, I'll just go ahead and call this 6 pi. Okay, and remember, units here are strictly just units, not units squared. Okay, then if I want to calculate to the nearest hundredth, I take 6 times pi, and I get 18.85 centimeters. Okay, last problem. Okay, this one I don't have a circle, so I'll go ahead and draw one. Okay, I have a radius of 4 centimeters. Okay, and my arc is 135, 90, 120, 135. Okay, so I want to find the length of this here. I'm going to actually color it in a different color too, so you can see exactly what I'm talking about. Okay, so that's what I want to find, and I know that that angle there is 135. Okay, again, 2 pi r times m over 360. So 2 pi, radius is 4, 135 over 360. Okay, so 2 times 4 is 8, so I'm going to take 8 times 135 and divide by 360. Okay, it gives me 3. So this is 3 pi, and my units are centimeters. Okay, then I'm going to go ahead and multiply it by pi. I get 9.42 centimeters. 9.42 centimeters. Okay, so that's it in a nutshell. Sectors, segments, and arc length. Remember, sectors are the piece of pi that you cut out. Pi r squared times m over 360. Segments, you take the sector minus the area of the triangle. And arc length is 2 pi r times m over 360.